We're on. Okay.
Cool.
Rich, it's great to see you again. And I thought we'd start out with me trying to summarize the paper you guys wrote. It seems like a white paper, a kind of position paper to sort of set the stage for what I assume is a strategy in DeepMind and a strategy, well, frankly, from knowing you for all these years that you've had. I mean, this is not new stuff. You've been saying this certainly since the 70s. Maybe the 80s. 70s may be a little hazy for both of us, but certainly the 80s.
Sure.
You and others have been pointing out that couple things. Reinforcement, or if you allow me to call it reinforcement learning. Now, this covers a couple things, and just to give some context, of course, I have a background in animal behavior, and reinforcement learning is something I'm very familiar. I've written a lot of papers on that as well, but for rats and pigeons, not robots. And it is interesting.
That's something very special about you, or that you and I share a little bit. We both have a background in animal learning theory.
Oh, that's right. I'd forgotten that. Tell me more.
Well, that is the origin of my participation in the field of reinforcement learning.
Right.
It's obvious that animals learn by reward and penalty, and it just was amazing that wasn't really in the various in AI and the various engineering approaches to learning. It wasn't present at one time. Now it's a standard thing, but it was a while when it wasn't a thing. And
well, of course,
AI guys don't know enough about psychology.
They don't know enough about the animal behavior and behaviorism overall. But we'll get to that in a second. Although in response to your comment, would you agree that if we look back at control theory, there's certainly a latent kind of reward, or shall we call it an outcome consequence for some action or some set of actions that lead to cooling a building or heating some part of a space, that is homeostasis. Now, it's hard to say that the furnace is getting rewarded, but nonetheless it is getting a control signal saying get it warmer, get it colder, and it's following rules to make things happen. And it's maximizing. If it did get rewards, it'd be maximizing rewards, right? I mean, if humans had to say, "I like the heat in here; it's good job, Furnace," then wouldn't the furnace basically be maximizing reward in that sense, or is that too simple?
Well, you could say that homeostasis and reward maximizing are similar in that they're both things about data, and they're things about interacting with the world and having an effect on the world. But you could also say that they're like opposites, because one is trying to drive things to zero, drive errors to zero, and it's told which way to move, and the other has to maximize something, and it isn't told what to do. It has to try different things and figure out what to do.
Right. So if the furnace didn't come with some built-in policies, then it would have to learn them based on something the human was doing in the room, that it could get some information about that state so that it could somehow improve the state of the human's, kind of trembling or or sweating.
But to go back to your initial statement that somewhere in engineering, surely there has been something like behaving to maximize reward, and there is a tiny corner of engineering, operations research, that does dynamic programming,
right?
And that is not about learning actually, but it's about reward.
Yeah, that's right.
It was about computing optimal policies to maximize reward.
Right.
Yeah.
Okay, well, so you tell me where I've gone wrong here in terms of me summarizing this paper, which I found, very illuminating in some ways. In contrast, just to set the stage in the other direction, of course, the huge change in AI in the last 5 to 10 years is deep learning, and deep learning is mostly, I'm not going to say, I'm going to be fairly general here, mostly about classification learning, mostly about category learning, supervised category learning, and the fact that it does a phenomenal improvement in benchmarks, sometimes by 150% if you look at the given context. So that's caught everyone's attention, maybe except for Elon Musk, who still can't get a car to drive autonomously and keeps running people over. But besides him, there seems to be, certainly Google and other groups are, Amazon is trying to figure out how to do autonomous driving at I think it's called level 4. I'm not sure what their categories are, but they have some designation of kind of robotic efficacy or something. Maybe based on Asimov, right? Do no harm, don't kill humans, things like that. But your claim is stronger. So there's this thing called artificial general intelligence, and it reminded me of the work that was done back in the 20s and 30s with psychologists, particularly L.L. Thurnstone and some others, who were saying there has to be something called general intelligence. Now, this, of course, led to IQ tests. It led to all kinds of strange biases because IQ tests are never properly normed, and they're a moving target because the item analysis itself is dynamic, and you can't really, the statistics underlying it is mostly horseshit, but that's a technical term. But nonetheless, when you've got correlations of 0.3 and you're trying to push that forward into a community and test their intelligence, my big worry is that someone in AI is going to discover IQ tests and start trying to use those on poor robots. But there's something else going on here, because Thurnstone and others had this idea that, and in fact, in terms of factor analysis, that there was some kind of general factor that was more common across all sorts of tasks and abilities that humans did. So it's not just that this guy was a genius, it's just that he had a bunch of common strategies and talents and abilities that somehow covered the scope of the space was much larger. And if you agree that that's kind of the definition here of artificial general intelligence, I'm not pushing it, I'm just saying that's one possibility, then you're saying that if we just look at an agent attempting to maximize reward under some general context, it will become, generally intelligent. Is that fair?
Yeah, that's pretty not unfair.
Okay.
Yeah.
So if we go with that, then go ahead.
I like you asked the question, what is AI? And that's what you're getting at. And
right.
I think the explanation you gave is kind of complicated. Whereas really intelligence is a simpler thing. It's just the computational part is the ability to achieve goals.
Okay. And you think that would be sufficient, therefore?
So you have to have a goal, and a modern way to formulate the goal is in terms of reward.
Yeah.
And so then you basically, anyway, if you have a computational ability to maximize reward, then you're intelligent.
So somehow, coming from, I was raised on Skinner, and I read Behavior of Organisms from front to back several times, the 1936 book. And it strikes me in reading that there's something very similar to what you guys are saying that feels like behaviorism. That is, I think you do comment on this in the paper, and you talk about internal representations, but there's something deep here. So if I said my cat is maximizing reward all the time, as far as I can tell, and it learns all sorts of strange behaviors in order to get food, nonetheless, is that sufficient to say that he has a general intelligence?
Well, it's intelligence is the computational part of the ability to achieve goals, and like abilities, of course, can have various degrees. So there's not like you have either have this ability or you don't have this ability. You have that ability to various degrees. It's not binary.
So what controls the degrees?
And cats, I think, are really intelligent. Like, let's just make that clear.
They've had a checkered past. I'll give you that. The Egyptians seem to be confusing them for some kind of gods at some point, but we'll leave that aside. Whatever the hell they were doing back then, but I do think there's a gap there
I want to go. You mentioned Skinner and behaviorism.
Yeah.
Okay, so I think we should deal with that.
Good.
Which is like there's a character.
He heard his name. Why aren't I on camera? He says.
So I think there's a sense in which the idea of reward seems kind of reductionist and almost demeaning. It sort of suggests that our lives are just about getting pleasure and pain, a scalar signal. And I think that's a real thing. I think we shouldn't run away from that. We should pay attention to that. Reductionism is not necessarily bad. We like the way physics can reduce things to atoms, and reductionist can be powerful. And I think that's what's, but it also seems, kind of annoying. We reduce things to lesser things. We reduce, objects and people to just atoms. But like for that one, we're used to it. We're used to thinking, I'm just a bunch of atoms arranged in a particular way, and the way they're arranged is really special. So I'm happy with it.
Well, yeah,
so
I spend every day, scanning people in MRI system, and my view of them is they're just bags of water, which I can flip some protons around in, and so I don't even get there. But I think the earlier.
So maybe we are just reward maximizers.
Yeah.
And that a really complicated reward maximizers interacting with a really complicated world, and that's okay. That reductionist does not demean us.
Well, except the critique on Skinner, of course, was that if you try to apply this to, let's say, language and developmental acquisition of language, you run into a kind of a conundrum identifying what the reward is. And often the examples are mothers trying to correct their children when they say, we go to the store. They say, no, we went to the store. And they said, yes, and we go too. So the problem is there seems to be some kind of ballistic, and this is where cognitive psychology comes in, in the 50s and 60s. Particularly, there's a great book that is worth bringing up in this context, which was something George Miller and Eugene Galantner and Karl Pribram wrote, called Plans and the Structure of Behavior, which prior to Ulrich Neisser was, of course, a complete rejection of behaviorism. Miller was just adamant. This kind of behavioristic, reductionist view of things was just not capturing what cognitive function was in a human. Now, in saying that, you could also say, and you did, rewards can be very subtle, and of course Skinner spent a lot of time pointing out that your environment, in some sense, arranges awards, or maybe you do, in the sense that, well, after I've washed the dishes, now I'm going to take a walk, or now I'm going to read a book, or, do something, have like a chocolate cake, whatever. And so there's a sense in which you're your own kind of reward manager. And then that somehow fits back into this internal structure that isn't really being captured by the reductionism, I don't think. That seems to be the big critique of this kind of approach, is that if you look at the internal states of the brain, okay, as opposed to the internal states, I don't believe there's a mind. I don't believe what philosophers say. I think there's a brain, and then in the brain there's emergent things, and things happen, and that's great. But it's mechanical. It's causal. There's a causal structure there. But it's very highly representational. That is, it has some relation to the world and the context around it that isn't. It doesn't seem as low dimensional as a reward maximization function. But maybe I'm missing something.
Well, there's a lot of things.
Sorry, I just.
So there's this whole controversy about behaviorism that ran its course many decades ago, and that we all have in our memory, institutional memory, about that there was a big fight and behaviorism lost, and behaviorism is bad. This is what we learned. We're not quite sure why.
It's evil.
But behaviorism is bad.
And Skinner's evil. An evil demon.
And then even old guys like us, it happened before we were alive, or before we were academics, before we were in school.
Yeah.
And so we were just left with this lingering memory. And yet, when we grew up and we went to school, we said, hey, this stuff about animal learning, this is cool. This is the fundamental principles of learning. These guys with the rats and stuff figured out some important things. And so we don't understand why it's bad, but we know behaviorism is bad because that's been passed down to us. Now, how do we square the circle? I don't know. I haven't really studied carefully the controversy, but it obviously doesn't apply to all the things that people are doing in reinforcement learning. We are not reductions. We're not trying to reduce the mind to simile and responses. There are things going on inside the mind, and I mean that's what we study. We study the algorithms by which things are constructed. We study the learning. We study the insides of the brain, of the mind. We are not behaviorists that are, in terms of restricting language and concepts to things external.
Yeah, but
okay?
Yeah. But you could look at.
This is my weak understanding of the controversy. The controversy was about you're not allowed to talk about what's inside, and that obviously doesn't apply to modern AI. AI is all about what's inside, what's in the mind.
Well, except that if we look at some of the successes of DeepMind with regard to game playing and benchmarks and so on, I mean, protein folding itself is quite a shocker. Although it's not really solved, but it's on the road. My goodness, and that's something where the internal structure matters. But then again, this is probably something more about biological knowledge and the way in which the algorithm interacted with that, which is why it worked. Now, the same thing with the game players. I mean, Jerry Tesoro. Was an amazing backgammon player. I played him, he always beat me. He was a terrible character this way. And so when he started to build TD gammon, it was a shocker to him that it started to beat him, because it just played itself like, I guess this is an early kind of GAN system where the thing is basically bootstrapping itself with a copy. Yeah, self-playing. So it would, in fact, eventually start to beat him, and that was a shock. But in all those situations, it's very hard to point out, other than behavioral observations. Okay, in the Go situation, I guess there was outcomes where certain openings or certain shapes of the pieces would appear that's never appeared, and they go, my goodness, this is shot. There's a level of creativity. But it's an inference, isn't it? It's not something about the internals of that machine, really. No one really took the machine apart and then tried to figure out, I'm happy for a bunch of mathematical equations. That's fine. Even if I don't understand them, at least I feel better. Somebody understood what was going on. And on the other hand, that's not very satisfying to our friends out there trying to push explainable AI, whatever that is. And what do they want? They want the AI to stand up on its, two legs and say, yes, this is why I did this. I was initially confused, but now I get it, or whatever they want. And I have to point out just sarcastically that most explanations really aren't very satisfactory when people give them to you in the first place. So I'm not sure where that tangent is going to take them, but it does highlight the point we're getting at here: is what are we actually maximizing in the sense of the internal representation or the structure? What is changing about the Go player that makes him so much better than that poor Korean champion that lost to the AlphaGo? What's inside of the thing?
That's actually pretty clear.
Okay.
It's changing its value function, its intuitive sense of when it's winning and losing. And it's also changing its intuitive sense of what move to make.
Okay.
So yeah, in reinforcement we call one, its value function is its intuitive sense of how well it's doing, and the policy is intuitive sense of what actions is to take. And it's learning those two things. It's learning an intuition about what's the best move and how well it's doing.
Now, if I was, would I be? Forgive me if I'd be too much of a reductionist to say, is that in the striatum or in medial temporal lobe?
It's great how the brain, we have the brain, we can reverse engineer it maybe, and then we have the theorists, the AI people, and they're all working on the same thing, different, like the elephant, the different ways of approaching the elephant and seeing it.
Right, but it does, I like your explanation of the, an intuitive sense of, how well I'm doing. And indeed, I do have an intuitive sense when I'm playing a game of, am I beating Rich Sutton or not at this game? And I don't know. And then that's confusing. And eventually I say, well, okay, I got his queen, so I must be doing better. And then he checkmates me. Oh, what the hell? So these intuitions can be wrong, and they can lead you astray. And something allows you to get better at that.
And we can learn them.
Yes, yeah. Something allows you to get better at that, and it's obviously the diversity, I guess, of the gameplay and the different trajectories in the gameplay that you can see trade off, or in other words, there's some meta picture of the gameplay that gets represented. And let's say those are like hyper parameters that are levers way up here, and we can learn those, kind of that hierarchy of meta levers, and then just kind of pull one up here, and then all the rest of them flow down. We get credit assignment out of that. So now we have this kind of like this very large mechanical structure that we're manipulating with maybe a few, parameters, a little epsilon here and a little alpha there, just enough to, reap the rewards of whatever that happened. Now, as that becomes thinner and thinner, that is the parameter control at the top is very, very a small dimension. You begin to lose, therefore, the causality between the little changes you made up here and the huge fact that you just have a general way of winning chess all the time. And so if that gets disconnected on you, you need to now then, I guess, trickle back down into the complexity and try to sort out where that went wrong, and then go back up to these meta parameters. So I'm just giving you a hypothetical way of filling that out as that intuition is this kind of high dimensional hierarchical thing that is reduced down to a few dimensions that I can talk to another human about. They say, well, how did you do that? He said, well, I lead with my queen or something, or when I start making pasta, I first find a very good basil. So obviously the pesto you're making, though, is more complicated than that, and yet you've reduced it down to a few things that isn't going to be very helpful to the next person making it unless they have a good model of this. But it sounds good. That's why I think explanations are basically bankrupt, because you really have to have an interface with somebody else who already pretty much knows, what they're doing. And then I can impart a lot of stuff fast, right? That's kind of the trick of this business.
Well, I think you and I just totally agree here. But we are both a little unusual.
Fair
the
enough.
main fact that we know is we study psychology a little bit. We know that whenever psychologists look carefully at a mental phenomenon, they find out that most of our intuitions about what's going on are wrong. We're not doing what we think, in particular about explanations. We are generally making up the explanation, saying, well, I did that, so why did I do that? I don't know.
Exactly.
I'll make up a story that fits in with my life.
That's right.
Yeah, and that is exactly what's going on. The explanations that people give are not the truth.
Right.
And they are after the fact. They're saying they're not what actually happened.
That's right. They're low-dimensional representations of the thing that actually happened. But then
low-dimensional, made-up stories about
absolutely
what's going on.
Narratives of your life, which are explanations, but they're satisfying to the extent that you're not explaining to 5-year-olds who will not understand what you're saying.
If you like illusions, they could be satisfying, but they're not real.
Not real.
Really what's
They're
going
not
on.
real. They're not real. That's right. But when you find two people agreeing on all that stuff, there is probably a shared sense of kind of experience or knowledge basis that does create a kind of a continuity in the communication. But
Yes.
I still think the business of artificial intelligence and general artificial intelligence is a long ways off. I mean, and I'm not sure that reward is enough. One thing that I thought I was going to read in here, and there was a little bit of it, was sort of the models and the internal models. Now, Philip Johnson Lard years ago had a thing called mental models, and there was a bunch of other folks that also subscribed to this. Now, it turned out that the problem was it was never implemented in any computational way or any even mathematical way that you could see, well, what is a mental model? And it became a vague kind of useless term, and various scions in the field attacked Phil viciously for years, and yet I think this goes back to another actually computer scientist named Kenneth Craig.
Kenneth Craig, 1943.
There we go. I thought we'd hit
The nature of explanation. I'm totally on board with models. Models.
Right.
Are one
So
of the
this is
four
why. But
big things.
don't you
Make
think
them-
that should be like half of this paper about how you make
No.
models?
No, it can't be, because
Okay.
the paper is about the problem side. It's not about the solutions method.
Ah.
Yeah,
Okay.
we're
I
saying
thought you.
The reward is enough for the problem of AI.
Ah,
It's not for the solution.
I see. Right, but in this case, we, especially with reinforcement learning, we have something where, if we're not talking about the model, but the way the solution occurs for the organism, it's got a set of options. It's got a kind of an equivalence class of things it can do. So even in a rat situation where it's pushing a lever, well, okay, I've got to push this lever. Should I push it with my mouth? Should I push it with my right paw, my left paw? Should I lay down and kick it? So it's got, maybe I should just bounce into it every once in a while, and food appears. So there's a sense in which this equivalence class of behavior doesn't matter. And the rat's model of this, unless you make the contingency so severe, you must push it with your right front paw and with these 3 little fingers you have and nothing else.
We want to have abstraction on the output side as
There
well
we
as on
go.
the input side.
That's right. But that abstraction leads to variance, and it leads to lack of solutions if the output side hasn't got a tight coupling with the outcome. So this is where learning educational systems break down, for example, because children aren't getting rewarded for things that they actually should be knowing. They're getting rewarded for lots of other things that may be incidental or distracting, and also ones that could feed certain kinds of deficits that are unknown when the child comes into, a kind of this raw contextual environment where they're supposed to learn something. But this is what I'm. Without understanding that model side, I just don't see how reward could be sufficient as artificial general intelligence. You really need the model.
The story is
okay
that reward is enough of a specification of the problem in order to drive the creation of a model. You need a model in order to get reward.
Okay, good. Well, but that begs the question: what's the modeling environment? Now, I guess ostensibly we'd say, well, it's a neural network, in the sense that we're creating a function approximator of some sort that can build an evaluation function.
The model takes a state and a way of behaving and tells you what the resultant state will be.
Yeah, but good old AI might have liked us to write down some propositional logic to do this, or
right, you might want to do it symbolically rather than
that's right
numerically with a neural network.
So are we at DeepMind rejecting the symbolic side of this dramatically?
There are aspects of DeepMind that are more symbolic than I would normally do, but I think mostly we've accepted the modern view that the symbolic thing has been a bit of a dry hole, and we don't want to just go back to the old ways.
Well, we don't want to be controversial or too controversial, but let's go back in time a tiny bit. And there's a person I knew, I suspect you knew too, who got himself caught up in defining general AI back in the 70s. And it turned out to be an enormous waste of billions of dollars.
Psych.
What?
Let Doug Lennett.
Whoa, you're good. You're good. Doug Lennett, my favorite guy. He has several quotes that we can. I have one right here. In 1989, he said, "Artificial general intelligence will be found, and what we need to do is find the 80 lines of code, because that's all it's going to be. 80 lines of code." And he said, "Psych," which was a knowledge system which was going to encompass all the world's knowledge through high school students typing into Lisp dolphin means and doing analogies of some sort between hospitals and schools and politics. That he would this would then become generally intelligent in 2001. Well, okay. There's some people predicting 2040 now.
And Doug Lennett was not alone. Marvin Minsky used to say, "Oh, we just get 10,000 facts, and then we'll be intelligent. Then we get 100,000, then we get a million, and it's got bigger and bigger." He was not alone. This was good old-fashioned AI, and it was the thing. And it's easy for us to make fun of it now. But
it's not that easy. I still think there's people saying things like this.
There are still people that hold on to that, but we have to have sympathy for them. Computers were small. A computer had some number of K in its memory, and. Yeah, the Big Mac. When the Big Mac came out, it was one of the early Macintosh. The Big Mac was 512K.
512K, I remember that.
That was the secondary memory.
I could do anything with that. That's an amazing amount of memory.
So, they were doing a technology that was sort of appropriate for what they had available then.
Yeah, but the hyperbole was. The question is what was in
what
was in Lynette's mind when he said things like this? I'm sorry, what'd you say?
The hyperbole was needed in order to get grants.
Oh, okay, that's right. Well, I was down at MCC during this time period as one of the representatives of Bell Labs or Bellcore at the time, and 4 of us got to go, if and only if we paid Admiral Bobby Inman $1 million. And every corporation, and there were 50 corporations that went down there, and then they had the couple $10-50 million from the U.S. government, because the Japanese were literally the boogeymen in this situation, and they were going to create something. They were going to wipe us out.
The Japanese. Fifth generation,
and we were doing the sixth, and how'd that work out? Didn't. So monumental failure with huge amounts of cash going down the drain, and nobody really remembers this, as far as I can tell. But it does strike an important part here, because the kind of stuff that you and Andy were talking about back in the 70s is a constant. I mean, you have never changed your tune. You actually have a fairly... I can't find you ever saying there's just 10 million rules we have to write down. And I looked. Trust me, I can't find you saying that. So you got a clean slate there. It's pretty amazing.
I've always been a connectionist. I still think of myself as a connectionist. I can't say neural networks because, these things are not neural networks. Neural networks already exist. They're in our brains.
That's right. That's right.
I can never get over that terminology.
It's tough because, yes, I still think of myself as a connectionist, but often if you go to, yes, of course, I saw you at a NeurIPS or NIPS /tilde IP, whatever the editing forms and said does it, fixes that. The NIPS. And what's remarkable there is that none of those kids know anything about connectionism. That sort of, because I said, well, I was like, part of this connectionist group, and they go, what? Okay, neural net group. Oh yeah. But it is. I mean, I'm always shocked when I go to that conference, and I'm amazed at what's going on pretty much on a weekly basis. Now, there was an interesting event recently. I was contacted by these two characters from Facebook, two kids. I want to call them Ben and Matt, but that's not their names. It was. They wrote a movie. That's right. I'm confusing them with the movie. No, they wrote a 500-page book called The Principles of Deep Learning. Have you seen this yet? Okay, well, it's on archive. It's coming out in 2022 in book form. It's literally 500 pages of text and maybe 300 pages of math. I can follow some of it. I talked to them for quite a while trying to follow what they were doing here. And they did everything asymptotically, but what they did do on page 331 was they wrote down the total gradient for a deep learning model of some unspecified depth, and it goes on for a few half page or so of this gradient, and then they basically look at it asymptotically to infinity and then try to make some interesting claims about it. And they do. I mean, there's some astonishing things they say in that book. I don't know if they're true, but it's pretty amazing. And it struck me that, okay, so they're actually trying to construct the internal inventory of what's inside of deep learning. And this was also being bandied about over in Princeton a couple years ago by a guy an Italian mathematician, I forget his name, who brought Jan and a few other people in to explain deep learning, and then they were going to do all of the theory and the math, and then figure out mathematically what it was actually doing. I'd gone to a couple of these workshops, and in the second or third one, I realized it felt like I was in 1988 again. These guys were explaining gradient descent and how complex that is. And that's the last I saw that. So and I don't think it really amounted to much until I saw this book, which I think might be important. I'm not going to make any claims about it, but it's shockingly well done. So, what implication it has something to do probably with training, initial conditions on training. But again, these seem like details to me relative to, artificial general intelligence, which of course is the larger issue here. And I don't think if you did the, complete mathematics of the geophysics of an earthquake, that would really give the same impression of what an earthquake is like, right? There's mismatch between the kind of let's call it rational explanation and the phenomenology of being in an earthquake, which is really quite different. And this gets back to these different levels of analysis that you were bringing up in terms of intuition and what I'm trying to, I think, suggest is something about the modeling that is missing here, and that neural nets aren't enough. Yeah, go ahead.
Let me try something on you. I mean, so let's first.
Okay.
As you say, deep learning, the renewed interest in neural networks is a great thing. It's been very successful. It's been an enormous explosion of work. If I was to criticize it, it would be sort of like it's an explosion, but it's also very narrow, and it's been kind of narrowing. But I think the most interesting thing to say, and you are one of the few people who may directly appreciate this, which is it's like David Marr. David Marr had his levels of explanation. He says the level of there's sort of a computational theory level where you get the principles, you talk about what is being computed and why that's the right thing to be computed, and he separates that from the representations and algorithms, and then that's separated from the physical implementation. So it's like brain, and then the representation and algorithms would really be like neural networks. That's the representation. And then there's the computational theory, which is actually more conceptual, and it's what you're computing and why. And that's what I've always felt has been missing. It's been missing in neuroscience. It's been strangely neglected in AI. AI, big controversies in AI are, should we use, neural networks or should we use symbolic rules? And that's at the intermediate level. That's like, how are we going to do what we're doing? Well, what the hell are we doing?
Right. Right.
And so I like to think that reinforcement learning is about what the hell are we doing? We're trying to maximize reward. We're trying to learn a value function. We're trying to learn a policy. We're trying to learn a model. Now that way of talking is all at this computational theory level.
Yes, that's nice.
What you're computed and why, and not how.
Right. That's nice. So it's more of a systems level analysis of what you're creating, what you're trying to create. Whereas whatever deep learning is doing, and we still don't know, is it does it really well, and the ability to classify, let's just call it the ability to create concepts, is at the basis, right? We know probably of these kinds of models that we need to have. And we know that, whatever semantics is, whatever the language structure is that we draw on, this is related back to what Phil was saying years ago. These are models that we can draw upon and reconfigure and mutate in ways that can make our abilities much larger than they actually are. I think frankly humans are fairly limited in what they can do, but we're really good at hiding it. And so we make sure that we can control the world around us, as opposed to us controlling the world directly. So, but philosophically, that gets back to, I think, the concern I have about reinforcement learning as a thing, because obviously, if people do things like, and I was trying to hint about that in the beginning, if they do things like, they're a writer, or they, sing songs, they like to dance. You can say there's intrinsic rewards for this, but no, they had to actually be learned somehow. And maybe this goes back to, kind of social evolution or something. But nonetheless, the reason the telephone is so popular, prior to World War II, people were saying, well, there might be a town will have one phone and you can drive from your town and then use that phone. No one could imagine a world in which everyone had a phone in their hand all the time talking to be. So the rewards here are not just subtle, they seem non-existent.
No, I totally disagree.
Good.
I think we should be past this. Now that we've seen AlphaZero and AlphaGo, those start with just, checkmate, just winning the game.
Yeah.
And they evolve, enormously subtle, complex notions of control of the king side and safety of things, and they can do enormously subtle and they have sub goals. They have a value function. They have sub goals. You can get enormous complexity out of a simple goal. If you don't, you can take AlphaGo and AlphaZero. Those get enormous complexity out of a simple thing. Or you can take evolution, which is all about reproduction, and it leads to all the complexity of all the different organisms in the world. You can have a simple goal and yet achieve enormous complexity.
I agree.
We should be used to that.
I agree with you on that, but there's a sense in which the goal and the outcome of achieving that goal has to be implemented, let's say, for sake of argument, in biology somehow. So there's a sense in which dopamine, of course, when I get a grant, I'm, part of my brain is just filled with dopamine spurts all over the place, going, wow, this, and that's producing a perseveration on my part to keep writing grants, even though the hit rate is so low. you still perseverate in these things. So there's something about the evolutionary persistence, before a species becomes extinct, if you will. And the same thing about AlphaGo. What is it did AlphaGo feel when it, won the game? What is it? What is it that implemented the reward? If you're just saying it's an algorithm, that's fine. But it seems like you're leaving out a whole dimension of the evolutionary mechanism that allows us to exist.
Well, we know about temporal difference learning. We know about value functions.
Yes.
And value functions mean you learn this subtle thing of, am I doing well? So like you're playing chess and there's no reward. The rewards are all zero until the end of the game when you checkmate or lose and or draw. But all during the game you have this subtle sense of, am I doing better? Am I doing worse? And that's all from the value function. There's no reward. The value function is learned from the reward. The value function is a prediction of the final reward. And each one of these little increases and decreases in value, these feel good, these feel bad. And so when you got your grant proposal, you realize your life is going to be a lot easier now than if you hadn't got that. And so even though there was no reward at that time, you had a realization that you were going to get a different reward in the future, different rewards in the future. And so you felt good. And as you say, dopamine filled your brain, because dopamine is not a reward. Dopamine is the TD error. It's the change in your value function at a moment. Yeah,
Yeah,
that's what dopamine
yeah,
is.
that's you should have been a psychiatrist. That feels very good as an explanation, but in the sense of if you actually have a dopamine release, you feel wonderful. And it's delusional because it's this kind of biochemistry that's producing some maybe secondary reward as opposed to primary reward. If we think about animal behavior for a minute in terms of, food and
It's
sex.
exactly the same thing as secondary reinforcement. It's the TDR. It's now we understand
Yeah, okay,
it as
okay.
the TDR.
Okay, but it shouldn't it?
And it should be there. You have just realized that you're going to get more reward than before.
So a robot.
So that is a really great thing.
I understand. So
Great.
a robot in the future arguably should have this, huge sense of well-being as that value function gets higher. It should, in fact.
Yeah.
Okay.
Yeah.
Okay. So this would be this wouldn't be
Yes, we do.
stupid thing to try to do, although it may seem adjunctive in that, of course, the robot will still do things to maximize reward, even though it's not feeling any better about itself. It's just saying, oh, well, I have to do this. My overlord masters are telling me to do this. I'm just a horrible robot. I have nothing better to do, so I'll maximize this reward. So I'm getting at this kind of disconnect between emotional states, which in some sense are counterfactuals, right? It's we have these emotions, and it's sort of like, what if this would have happened? What if that would have happened? And in some sense, in a reward, goal system, there's a bunch of counterfactuals being played out. What could happen here? I could do this. I could do this. And then if I did, I'd better say this could happen. And then my value function will go, wow, that's where we're going. We're going to win the lottery this time, or whatever. And then there's some risk system that's saying, yeah, you never win the lottery. Don't spend so much money. Do something else. Go back to work. So there's a whole bunch of competing goals out there, and they all have to somehow come through a final common path, and they all are implemented in different ways, I think.
Cool. So we have these all different. Okay, so I believe in reward. I believe in what we call the reward hypothesis, is that all goals and purposes can be thought of as maximizing a single scalar signal we receive from the world. And it's also, I've become comfortable with that. It took me many years. Most people will not be comfortable with it. You're still a little bit anxious about it. I can tell that.
Less so than you would imagine.
This is where you get relaxed about it. You say, oh yeah, I want to get money, and I want to have a big car, and I want a big house, and I want to have personal relationships that are satisfying. I want all these things. I have multiple goals. But really, those are just part of getting a reward.
Yeah.
And then there's the world. The world intervenes. We realize, oh, if I, get this really fancy car, maybe I won't be able to afford the nice place to live. And I have to trade them off. The world intervenes, and it forces me to make choices.
Right.
And so now I see it as, do I want this goal, or do I want that? Literally, there's just one goal, and the world, but the world does intervene and mean you can only achieve some things. You can't do everything. So you have to make choices apparently between the goals, but it's really between strategies to get the one ultimate reward. And you could say, sometimes we say, well, I don't know how to trade off, a good work life and a good home life and a good work life, and it seems incomparable. And I want some answer to this, but we are actually really good at doing that trade-off. That's what people are. They do the trade-offs. They can decide, should I have the chocolate cake, or should I get?
Should I go back on the running wheel? Yes.
That's right.
So
we make those choices. That's what we're really good at. We're good at trading off the different goals and deciding which ones we really want.
Well, I'm looking forward to this DeepMind robot someday, but before we get there, we're running out of time, and I don't want to hold you up much longer, but I have one little anecdote for you, so which may put some of this in a different perspective, maybe not, I don't know. Well, let's see. So have you ever heard of going back to animal behavior where we started out in the beginning here, have you ever heard of the free food effect? Does that sound familiar at all?
No.
So back in the 70s, people would put animals on fixed ratio schedules, and they'd sit and they'd press the bar, 3 times and get some food, 4 times and get some food, and so forth. Well, there was a kind of a insight when people started watching inside the Skinner box. Animal was in between times when they were pressing the lever on task and times they were eating out of the hopper. They would wander around the back, and maybe they'd pick up some wood chips and start chewing on them, almost like in a stressful way, and then come back into the lab. So some clever researcher said, maybe I'll just put a bowl of food in the back and see what they do with that, since frankly what they're doing, they're getting rewarded for pushing this lever to get food. What if I just break this economy and put food in the back? What would they do? Well, they don't eat the free food. They leave it alone. They enjoy the task so much and the reward that they're getting. In other words, there's something virtually important about the work, which was really astounding. Now, the animal, when the lever was locked, would go back and look around the feed food, eat some of it, but then immediately go back and see if the lever was unlocked. And this was dubbed the free food effect, in that it wasn't much of an effect at all. That is, animals were not socialists, apparently. They liked the meritocracy of getting food. So I think the only thing I'm saying there is that rewards are also high-dimensional things, and I think it's going to play into this in a way that allows us to try to factor these robots in different ways. And I'm not sure how to do that, but I do think that rewards are not, that just doesn't go back to my dark chocolate mints that I like. There's something that is cognitively important about this. But I'll let you have the last word, and because I enjoyed this so much. This was I can't believe an hour just zipped by.
Yeah. So rewards, we don't know what our rewards are, and probably rewards involve things like intrinsic motivation. Well, what does this fancy word mean? Intrinsic motivation it means we do value understanding the world, and separately from obtaining the what we might imagine are the immediate benefits, such as food and drink, but just coming to understand the world is important to us. Okay, so does that mean that reward has to be multidimensional? Maybe, but maybe not. I just love the simplicity of there being a single number, and I'm going to hold on to that as my null hypothesis for as long as I can.
You don't like tensors, hey?
It becomes conceptually it's just much more.
It's much cleaner.
Unclear.
It's much cleaner.
Yeah.
Well,
but the final point I think is that we are not just. What is a person? What is intelligence? Intelligence. The interesting way to say it is that we are beings that try to understand our world, and by understand the world, we mean predicting and controlling our data stream. And if that's the goal, is to predict and control it, in all of its complexity and subtlety, that's what it means to understand the world. That is a never-ending activity, and that is separate from getting something. It's like getting an understanding, getting knowledge. I think a lot of our life is concerned with getting knowledge. Certainly ours as academics is concerned with that, as well as getting a nice job and a place to live.
Yeah.
In the respect of our friends, hopefully.
I can't agree more. This is been one of the most simpatico talks I've had, where I find myself feeling as though you're taking the words right out of my mouth, and I'm taking them out of yours. So
Exactly.
and I think
I agree
I think
too.
there is something about just the shared kind of background in starting with animal behavior and moving through this evolutionary kind of path, which I think most computer scientists don't get, and I think that can be a problem in terms of the, what Dave Rumelhart used to call proof by lack of imagination. And I'm going to